Okay, here we are, section 10.2, angles and arcs. And the first section was some review information on circles and parts of circles, your radii, your diameter, your chords, and circumference of a circle. In this section, we start talking about something that we'll be talking about throughout the rest of this chapter, is arcs. But before we do that, we must talk about what a central angle is. So a central angle is exactly as it sounds, using contextual clues. The word central, meaning deriving from center, will tell you that an angle whose vertex is clearly the center of a circle and whose sides are radii of that same circle. Now, I don't much go along here, but use the contextual clue, central angle. It's going to be the angle whose vertex is clearly the center, so our example would be angle ACB. Now, if you look at that central angle and take a look at all of the angles going about the circle, the central angles, you'll notice that they all would add up to equal 360 degrees. So now let's talk about arcs and the measure of those arcs. As you can see here, we have central angle ADC, whose measure is 49 and varies according to how far I move point A around the circle. But what you'll notice is if I reveal to you what the measure of the arc is, first of all, you'll notice that it is also in degrees and also matches whatever the measure of the central angle is. So I move A so that the angle is wider, larger. You'll see that arc ABC, which is formed by that central angle, will move as well. So with that, the definition of an arc, some of you, especially in honors, have already seen this with your Mobile project. We talked about this. An arc is simply part of a circle. And there are three types of arcs. The first one is a minor arc. And the word minor, looking at its contextual clues, means, it's not working with me here, small. And if we're talking small, we're talking lesser, as in less than 180 degrees. So the measurement of a minor arc will always be less than 180 degrees. So how do we note it? You need to note the difference. Remember, there are different ways to go around the circle. Which way you're going? You going short side or the long side? Well, the short side, meaning would be the small minor arc. You simply use the two endpoints. And as we proved earlier on the Sketchpad demo, it will always equal the measure of its central angle. So if this angle, angle BCA, has an angle whose measure is 60 degrees, you'll see that the measurement of its intercepted arc, and I like to shade or color my arcs, makes it kind of look like a pizza or a slice of pie, but that is what we're finding. We're finding the measurement of that red arc, that part of the circle. Now later there are other special types of segments and arcs that will be used. You want to make sure that, again, you highlight these so you can see how you find the measurements of either your arcs or your angles. So in this case, with our notation, we can now name arc AB with the appropriate notation and say that it equals 60 degrees. Well, if we have a minor arc, you know we're going to have a major arc. And once more, major being the opposite of minor, being the opposite of small, means that our major arc would be large. And if it is the opposite of the minor arc, which is less than 180, it makes sense that ours would be, the measurement of our major arc would be greater than 180 degrees. However, the notation, we need to be clear and precise. Again, there are two ways to go about a circle. We've got this short way going from A to B, but then we can also get from A to B going the long roundabout way. So we need to be specific about when we're talking about our arc going from A to B, which arc we're alluding to. Well, that comes in and using the two endpoints and the point on the major arc. So our major arc in this case, to be clear, would be the measurement we're going to find in a moment of arc A going through D and stopping at B. It would equal, well, let me ask you, if the blue arc is 60, the rest of it would have to be, well, if you said 300 or thought 300, you are correct. And how do you do so? Well, you take 360, saying that all the way around the circle is 360 degrees, and subtract the measurement of the minor arc or the acute central angle. So we've got less than 180 degrees being a minor arc. We've got greater than being a major arc. So now it's time to have one that is right on or equals 180 degrees. And that type of arc is called a semicircle, which if you look at our diagram, you'll see is half of a circle. And because it's half of that 360, its measure will indeed be, like we set up earlier and above, 180 degrees. But you've got to be careful again. There are two ways to go about a circle, especially half. We've got this one that is going top side. We've got the one going bottom side, so we need to be specific. We'll call this point Y. And if I want this lower semicircle, you'll notice I started at A, went through Y, and stopped at D. So we would say this, call this the measurement of arc AYD with the arc notation equals 180 degrees. Now, a few relationships that exist amongst our arcs. One is kind of a common sense. It's our first theorem. Let me ask you, if I named these two angles, angles 1 and 2, wouldn't we know these two angles to be congruent? Because they are vertical angles, so they are congruent. But if their measures, congruency means having the same measure, if their measures are congruent, then wouldn't their intercepted arcs be congruent as well? And that's exactly what Theorem 10.1 states. It states in the same circle or congruent circles, two arcs will be congruent if and only if their corresponding central angles are congruent. We'll go to the next relationship here. We have 45 degrees, and we have this being 60. So if I were to ask you, what is the measurement of this arc? I would hope you would tell me that it would be 45 degrees. If I were to ask you to give me the measurement of this arc here, I'm hoping you would be able to tell me that it would be 60 degrees. But what if I asked for this major or big arc here, bigger than the one that was provided? I'm hoping you would say that you would have to add them. And that is indeed the case. We've done segment addition postulate. We've done angle addition postulate. I now introduce you to the arc. Arc addition postulate, where we can get that the measurement of the arc, we'll call it AC, with B being in the middle. The measurement of arc AC would equal the measurement of arc AB plus the measurement of arc BC, which would be our 45 plus 60, which would give us 105 degrees. On to our final item, and for honors, you've already seen this. But the length of an arc, we already know that an arc is part of a circle, and we know that the measurements of arcs are in degrees. But if we want the length of an arc, Just like an arc is part of a circle, wouldn't the length of an arc be part of, well, the whole thing around the circle? The whole distance is the circumference. It would be part of the circumference. So to close, the arc length can be found by taking the measurement of the central angle divided by 360 times pi and d, which is diameter. For central angle over 360 will give us our fraction or part of the circumference, pi times d. Any questions? You'd like to see any examples? Please look in your textbook. Make sure you have the homework done that is listed above on the blog. Until next time, I bid you adieu.